All right, welcome to this session of Krazifizix Medicine Science Clinic. Again, you can reach us on our details as usual, www.krazifizix.org.za. Send us a message at info@krazifizix.org.za. Also, you can reach us by phone, WhatsApp on 0817442103. All right. We are looking at electrostatics again, and this is our activity session on electrostatics. I hope the first two videos have been helpful. There are two videos before this in case you are getting a hold of this session. So this session, we're just dealing with activities, as many as possible, in 1 hour. All right, so let's run. All right. We have a question here, a multiple choice, and then we'll run to a structured question. Two charged particles are placed a distance r apart. The electrostatic force exerted by one charged particle on the border is Fe. Which one of the graphs below correctly represents the relationship between the electrostatic force Fe and the square of the distance between the two charges? All we need to remember here is our law. The law states that the electrostatic force now is inversely proportional to the square of the distance. This is wrong. This means constant here. This is wrong, and that is correct. Inversely proportional. If you go back to video number 1, we did a little thing on graph, so you'll get the correct answer there, but it's all in the law. All right. Now we have another question here. Okay, we have another question. A metal sphere A, now we're dealing with structured questions. A metal sphere A suspended from a wooden beam by means of a non-conducting string has a charge of positive 6 microcoulombs. All right, let's talk about this. This is the first time we're talking about this conversion in our video. All right, this is 6 times 10 to the power negative 6 coulombs. If it is nano, then it becomes negative 9. All right, where electrons added or removed from the sphere to obtain this charge, assume the sphere was initially neutral. Okay, let's check. Now, my sphere was initially neutral. If you go back to the first video again, this question was answered. Now, if we add electrons, because electrons are negatively charged, my sphere becomes negative. All right, because it has more what? Electrons. If I remove electrons, I am removing the negative charge. Automatically, it becomes what? Positive. Let's go back to our question. It has a charge of positive, which means electrons were removed. Electrons were removed. Calculate the number of electrons added or removed from the sphere. We're talking about number of electrons. Video number 1, grade 10. N equals to Q over E, and that is what? 6 times 10 to the power negative 6 over negative 1,9, negative 1,6 times 10 to the power negative 19. The negative, you will see what it will actually help us to do. All right, so let's run to our calculator like we always do. 6 times 10 to the power negative 6 over negative 1,6 times 10 to the power negative 19. That answer, that constant is on the formula page. All right, so just run to the formula page and quickly check. What will my answer be? Negative 3,75. All right, remember, the negative is only showing you times 10 to the power 13 electrons. The negative, if I put a negative here, it's only showing us that it was removed. Negative, we remove it. So the number of electrons removed is actually 3,75 times 10 to the power 13 what? Electrons. That is what was removed. Great. Point charges Q1, Q2, and Q3 are arranged at the corners of a right angle triangle as shown And the diagram below, all right, we have that right angle triangle there. Okay? It now says the charges on Q1, let's move this up so that it's visible. The charges on Q1 and Q2 are positive 2 and negative 2 microcoulombs respectively. And the magnitude of the charge on Q3 is 6 microcoulombs. Alright. The distance between Q1 and Q2 is R. The distance between Q2 and Q3 is also R. The charge Q3 experiences a resultant electrostatic force, alright, a resultant electrostatic force of 0.12 newtons to the west. Okay, to the west, which means it comes this way. Is that fine? Alright. Now, the question now says, without calculations, identify the sign, either positive or negative, that is on charge Q3. Alright, let's try to do this in a very simple way. What we know is this, that we have Q3 here, and we don't know the charge. But one thing we know is that the electrostatic force, net electrostatic force, F net, is here. Alright, to the west. Now, for this to happen effectively, what do we need to have? Alright, if I'm looking at my net force, I want you to look at this very, very creatively. If I'm looking at my net force, we're going back to our grade 10, where we are drawing tail to tail and tail to head. Okay, so this is my net force. Let me bring it down. Here's my net force, F net. Now, if I need to draw F1 and F2 that's resolving this, I would need to actually create something like this. I want you to see this. Okay? Because I'm looking at my angle there, you see? I'm looking at this. Is that fine? And I'm also looking at this. So that my net force now comes this way. I don't know if that makes sense. Let's try that again. This is just beautiful. My net force is this way. If I look at this plane, which means I have a force going that way, tail to tail, and I have a force, I have a force going this way because it's on a straight line. I have a force going that way, I have a force coming this way, therefore my resultant comes that way because I can now complete this triangle and have that. Alright, now what do you think will be Q3? For Q3 to move away, remember our focus is on Q3. The question says the charge Q3 experiences. So what do you think will be on Q3 for Q3 to move away from Q2? It has to be negative. But let's check, will that work? If Q3 is negative, what will happen? The force of attraction between Q3 and Q1 will be in this direction, attraction. Alright, that means confirmed Q3 is negative. Negative. I hope that makes sense because of the net force to the west. So this is about knowing how to draw your vector diagram. Grade 10, tail to tail, tail to head, and your resultant force. Draw a vector diagram. Now you see what the examiner wants. To show the electrostatic forces acting on Q3 due to charges Q1 and Q2. What do we use? We use a dot. Okay, so I'm going to have my straight line there. Okay, let's try to draw a straight line here. I'm going to have a straight line there. Okay, and I'm going to have another one there. Nice, perfect. What is this now? This is going to be F2. This is going to be F1. Remember, this is Q what? Q3, negative here. So you see here we have a positive, so there's an attraction. Here we have a negative on the side, which is actually now pushing this away. Hence my arrows are pointing in that direction. So that's your vector diagram. It's 2 marks. Write down an expression in terms of R for the horizontal component of the electrostatic force between Q3 and Q1. Okay, write down. Let's try to look at how to do this. Write down an expression in terms of R. Okay, we don't know R. For the horizontal component of the electrostatic force exerted on Q3 by Q1. All right, let's work through this now. Now we're looking for the force exerted on Q3 by Q1. So number one, my focus is F equals to K Q1 Q3 over what? R squared. Is that okay? I'm going to come back to the horizontal component part. All right, so I've got this. What is F? K now is 9 times 10 to the power 9. What is my Q1? 2. Remember here we don't deal with the charges, the signs. What is Q3? 6 times 10 to the power negative 6 over what? R squared. And what will this be? Running to our calculator quickly, we have 9 times 10 to the power 9 times 2 times 10 to the power negative 6 times 2 times 10 to the power negative 6. What do we have? We actually have 0,036. All right, 0,036 over what? R squared. That is my F. But that's not my answer, because the question now wants the horizontal what? Component. I'm going to do something to explain that right now. Here is my Q3 and here is my Q1. There is a force of attraction here, which is what we got, F1. But now, remember that I'm going to come back to my diagram here. If this R is equal to this R, that means, and we are given that this angle is what? 45. It automatically means that this angle here is 45 as well. All right. Now we're looking for the horizontal what? Component. Let's check something here. Here's my force. Let me use a blue ink here. This is now my what? Vertical what? Component, F1Y. And what is this? This is my horizontal what? Component, which is what? F1X. Now we are looking for the horizontal what? Component. Remember that this angle now is 45 degrees. What do I now do? Okay, grade 10, equal forces. It means I can have this as my F1X. I want you to see this right angle triangle that I'm putting now in green. Now, what do we know? I am looking for this. This side is opposite, all right? This is my 90 degrees. This side now becomes hypotenuse, which is my F1. And this side becomes what? Adjacent. So, what is my F1X? My F1X is the adjacent and hypotenuse. So, I can simply deal with cos 45 equals to adjacent F1X over F1. So, what is my F1X, which is my horizontal component? F1 cos 45. Where F1 is the force between Q1 and Q3. And remember what we got? We got 0,036. 0,036 over R squared cos 45. All right, we can expand and write down our answer in full, but the question says in terms of R squared. Okay, so what is 0,036? Cos 45. Let's go check that. Answer cos 45. What do we have? 0,025. 0,025. Okay, let's just make sure that, let's go back and check all our calculations. Okay, we have 9 times 10 to the power what? Sorry, 9 times 10 to the power 9 times 2 all right, times 10 to the power negative what? 6 there, all right, times 6 times 10 to the power negative 6. That gives us what? Ooh, we made a mistake. 0,108. Figure I did omitted something while I was I omitted something while I was trying to multiply. 9 times 2 times 6. 0,108. Oh, okay. I think I put a 2. 0,108 over r squared. I hope that makes sense. All right. Now that costs 45. Costs 45. That multiplied by costs 45. So answer costs 45. We're going back there. 0,076. 0,076. All right. This should be 018. 0. I repeated a 2 while I was doing that earlier. So what's my answer? My answer is 0, what? Let me check that again. 076. 076 over r squared. That's my f1x, and that's my answer there. All right. The next question says calculate the distance r. All right, calculate the distance r. How do we work through the distance r? Remember, we are given a resultant force. So do we use our resultant force here? Let's see. Okay, how do we work this? Now, we do know that already we have our F1. We can now calculate. Let me try to bring that diagram back to mind, what we drew earlier. We had that. No, it was in the opposite direction. Okay, all right, this would not, let's remove this now. All right, delete that. We delete that as well to have a clear space. We also delete that. Now, my diagram looks like this. That's the first force, all right? And that's the second one. Remember, that was my free body diagram, which is also my vector what? Diagram. All right. So we do have that, and I have a dot there. And we label this as F2, and we label this as what? F1. Okay. If I were to find my component, let's quickly check my component. My F1x, remember what we said. Let me try to use something else for F1. F1x, all right. F1x. So I'm going to have F1y here, my component, and I'm going to have what? My F1x there. All right, good. That is F1. What will I have for my F2? My F2 is going to be vertical, all right, resultant now, and I'm going to have that there again. I hope that makes sense. So let's label this. What is our labeling going to be? This one is F1y. This is what? The blue one. Okay, why don't I just use a blue? All right. F1y, F1x, and then on the F2, we are going to have the same there. We're going to have what? F2y and F2x. By the way, the resultant, do you remember the resultant? The resultant now is a combination of these two in the same direction. When two forces are in the same direction, what do? We add. All right, this is just lovely, which means that F1x plus F2x, because they are in the same what? Direction, is equal to my 0,12. Remember that we were given that 0,12 to the west. So why not just west as positive? So both of them are positive, positive. We have that. Okay, now already we have an expression for F1x. we need to get an expression for F2, which is going to be basically the same thing, because here we said 2 multiplied by 6, remember that, and here again for F2 we are going to say 2 multiplied by 6. Let's just put it down. So F2 will now be equal to what? K Q2 Q3 over what? R squared. 9 times 10 to the power 9. What's my Q2? It's 2 times 10 to the power negative 6 times 6 10 to the power negative 6 over R squared. Remember earlier on, we got 0,108 over R squared. But if I were to deal with my component now, what will my component look like? Exactly what we did the other time. Okay, this is my F2, remember? And we are given the angle as 45. It means this angle here is 45. All right. Now, if I'm looking for my horizontal, let's just do this so that everyone, it's clear for everyone. Let me use something else now. So now that I'm dealing with this, I'm looking for my horizontal what component. By the way, let me keep the color code. I'm looking for my horizontal component, which is right here. Okay, that's my F2 what? That's my F2x as well, my F2x. Now, if you look at the side, this side now is opposite. Okay, that is opposite. So I can now say that my sine 45 equals to F2x divided by what? F2. So my F2x is F2 sine 45. I hope that makes sense. So can I come back here and say my F2x is what? F2 sine 45, which is basically 0,108 over R squared sine 45. And if you know your mathematics, sine 45 and cos 45 are basically the same. So I'm going to have 0,076 again. 0,076 over what? R squared. I hope that makes sense so far. This is basically taking you back to understanding forces in grade 10 and 11 term 1. But we now know that F1x plus F2x is equal to 0,12. So 0,076 over what? R squared plus 0,076 for R squared equals to 0,12. Okay, now this physics is done. What we need to do here is to mathematically now solve all of this. All right, these parameters here are the same. It's like saying x plus x, and x plus x is 2x. So I can easily come here and say 2 multiplied by 0,076 over what? R squared equals to 0,12. I hope that makes sense mathematically. Otherwise, you have to find the lowest common multiple here, which will still get you the same thing. All right. Okay, running out of space now. Running out of space. What do we need to do here? Okay, I think we can just manage this small space. It's just the math that is we need to do now. We can divide both sides by 2 so that we now have, I'm going to manage the space because I don't want to leave the screen. I'm going to divide both sides by 2. 0,076 over R squared now should give me what? 0,06, because if you divide both sides by 2, your 0,12 divided by 2 will give you what? 0,06. Now what do we do here? We can easily cross multiply, and if you know your maths, it's quite easy. So, but let's work through with everyone. All right, I want to make sure we work through with everyone. So permit me to manage the small space. 0,06 R squared equals to 0,076. And what do we do now? We divide both sides by what? 0,06 and find the square root. So R should be the square root of, first you divide by 0,076 and then find the square root, 0, what? 0.6. This is mathematics. All right, let's run to our calculator now and get a final answer. So we are saying the square root, we're dividing 0,076, all right, divided by 0,06, 0,06, okay, 0.06, 0,06, no, 0,076 divided by 0,06, and we find the square root of all the number there, and my final answer is simply 1,13. All right, 1,13. 1,13. Let's make sure that everything that we did was imputed correctly. All right, 1,13. Remember, we have to round off to 2 decimal places. We have to round off to 2 decimal places. So our answer is 1,13 meters. So that's my R, 1,13. Okay, now, so this question, I like the mathematics involved. It's a lot of mathematical expression that we needed to talk about, but that's how you work things out now. I hope that was clear enough. Okay, we need a new page quickly so that we can continue to 7.3. 7.3. All right. Okay, I'm going to have to go look for my question again. All right, let's just copy this page. Okay. The magnitude of the electric field is 100 Newton per coulomb at a point which is 0.6 meters away from a point charge Q. Okay, it's a different question completely now. Define the term electric field at a point. All right, this we need to know. Electric field at a point. All right, electric field at a point. Remember we said E equals to F over Q. It is the electrostatic force. Electrostatic force experienced. All right, electrostatic force experienced per unit what? Charge placed at a point. Okay, placed at a point. So basically it is the force experienced per unit what? Charge. Now, the next one says, calculate the distance from point Q at which the magnitude of the electric field is 50 newtons per coulomb. Let's get that because we now have two things. It says the magnitude of an electric field is 100 newtons per coulomb at a point which is 0.6 away. So we have something like this. We have Q and then we have a point P, 0.6 meters, and the electric field here is 100 newtons. All right, that is experience at a point P. Now the question says calculate the distance from point charge Q at which the magnitude of the electric field now should be 50. Okay, now we need to carefully look at this. Number one, we don't even know what charge Q is. So that will actually first create a problem. We need to find Q. Let's see, there could be two ways to do this. We don't know this charge, but I know that my E equals to what? K Q over R squared. So basically, I'm looking for a point here where this now becomes what? 50. That's what I'm looking for, 50 newtons per coulomb. All right, so if we look at E equals to K, what is our E? 100 equals to 9 times 10 to the power 9 Q over what? R squared. Oh, by the way, I know this distance here because I'm dealing with P, 0.6 squared. Okay, cross multiply 0.6 squared multiplied by 100 divided by 9 times 10 to the power 9 equals to Q. I know by now your mathematics is been sharpened and you know what we did there. So we have 0.6 squared multiplied by 100 divided by 9 times 10 to the power 9. And what do we have? 4 times 10 to the power negative 9. So Q now is 4 times 10 to the power negative 9 columns. Alright, now I am looking for E. No, I know my E now. My E now, again, I'm going to use the same formula, KQ over what? R squared. But my E now is what? 50. 9 times 10 to the power 9 times 4 times 10 to the power negative 9 over R squared. This is what I'm now looking for. Mathematically, R squared now should be equal to 9 times 10 to the power 9 times 4 times 10 to the power negative 9 divided by 50, because all we need to do is to cross multiply and divide both sides by 50. What's my answer here going to be? It is now 9 times 10 to the power 9 times 4 times 10 to the power negative 9 divided by 50. I hope we have all our calculations in place. Yes. And my answer now is 0.72. But this is R squared. What am I looking for? Square root of my answer. I should be having 0.8485. And remember, we have to round off to 2 decimal places. What is my answer? 0.85 meters. So R is 0.85 meters. All right. Good. 21 marks. Lovely question here. Please rewind the video and watch it over and over again until you get a grip of what we did. This question is quite mathematical. There's a lot of mathematics in it. All right. Next question. All right. We're bringing in a new dimension of question here. A small sphere Q1 with a charge of 32 times 10 to the power negative 9 coulombs is suspended from a light string secured to a support. A second identical charge Q2 with a charge of negative 55 times 10 to the power negative 9 is placed on a narrow cylindrical glass tube vertically below Q1. Each sphere has a mass of 7 grams. Now they're talking about masses. Both spheres come to equilibrium. Equilibrium grade 11, first law, Newton's laws. When Q2 is 2.5 centimeters from Q1, there's a problem there with the 2.5 centimeters. We must convert to meters. Quickly, let's do that one very fast. I always like to do my conversion immediately. Divide by 100. What am I going to have? 0.025 meters. All right. Okay. Ignore the effect of air friction. The first question says, calculate the number of electrons that were removed from Q1 to give it a charge of positive 32. Remember, when we remove, it's neutral. When we remove, we are going to be left with positive charges because we are removing what? Electrons. All right, let's see. How many electrons were removed? What do? We now say N equals to Q over E. What is our Q? It is 32 times 10 to the power negative 9, all right? Is that okay? Over. Now, what are we doing? We are removing, okay? Negative 1,6 times 10 to the power negative 19. Hold on here. Now, before we removed, hold on, it was what? 0. If you are removing, we're removing a number of electrons, all right? So that the charge becomes what? Positive what? 32. You know what it means? It means we have removed a quantity of electrons of negative 32. I want us to get that before we continue. It's a neutral charge. It's a neutral. It's 0. Is that okay? It's like your number line. If you remove negative 32 electrons, you are going to be left with positive 32. Why? If you were to add this negative 32 back, you're going to get what? A 0. So the quantity of electrons removed is negative 32. Removed. Negative 32 were removed. So what's my answer here? So that's why I am putting the negative there. And in case you get across to see some other solutions, you might be wondering, why is there a negative there? That is what I just explained. Negative because we removed negative 32 to be left with positive 32. Remember, it was 0. So we are saying, what did we remove? We removed negative 32 columns of electrons. All right, so what do we have in calculating the number of electrons removed now? We're going to have 32 times 10 to the power negative what? 9. All right, please let's be careful with exponential. You've seen some of the imputing mistakes we've done in this video, and I'm glad because you've seen the video and we're walking through together, looking at common mistakes that are made. All right, so you are aware of them. 2 times 10 to the power 11 electrons were removed. 2 times 10 to the power 11 electrons were removed. I hope the negative 32 makes sense to you there. 2 times 10 to the power negative electrons. So if we remove electrons, we are going to be left with positive charges. Draw a labeled-free diagram showing all the forces acting on the sphere Q1. All right, let's look at Q1. What do you notice is acting on Q1? Number one, Q1 has a mass. Automatically, what are we talking about? We're talking about a weight there. All right. Q1 has a mass. Okay, so I'm going to have that. That's my force of gravity. What else do we have? We have an electrostatic force. Okay, electrostatic force between Q1 and Q2. And because they are naked, they are opposite charges, they are going to what? Attract each other, which means Q1 should be moving down because of the charge. All right. Now Q1 should be moving down. I should have, okay. Q1 should be moving down. I'm going to have 2 arrows there. All right. The electrostatic force is actually stronger than the gravity, the force of gravity there. Okay. Let's try to, let me do something here just to make this diagram a bit more visible. I want this diagram to be more visible. Okay. Just for more visibility. Please, it is important that we understand the magnitude of the forces. All right. We must understand the magnitude of the forces. So I have one force going down. Okay. I wanted my gravity a bit smaller. I want my gravity a bit smaller. All right. No. Okay. Yeah, you know, technology sometimes. All right. That's my gravity. And I have my electrostatic force a bit longer. All right, a bit longer. You can, now the thing is, these lines must be parallel, please. When we draw our free body diagrams, they must be parallel. Okay, I'm just trying to get a good diagram so that we can see what I really want to do. I just want to get something perfect. All right, I want to get something perfect. Okay, so I'm going to draw it side by side just to get the point, exact point. Oh no, now I have different forces. All right, good. Just going to walk through that. Just trying to make it look nice. Delete that. And we delete that. Good. And now I have my forces. Now remember again, let's go back to the question. There is also what? Tension. Anytime you see a string, what are you talking about? We're talking about what? Tension. So I have a dot there as a free body what? Diagram. Tension will be acting where? Upwards. Is that fine? My tension is acting upwards. So let's quickly label all these forces. What is this? Tension. Please let's write in full. Tension. What is this? Electrostatic what? Force. Electrostatic force. And what is this? This is the weight. And you have your max there. Good. Calculate the magnitude of the tension in the string. Now the question actually says that this thing comes to equilibrium. When it comes to equilibrium, you know what it means? It means my F net equals to what? 0. So let's take it downward. Take it downward as positive. So what do we have? F net will be equal to, because it's at equilibrium, it means that all my forces, now if my downward force is positive, it means my upward force should be negative. So what are we going to have? We're going to have what? Our force of gravity plus our electrostatic force minus negative what? Tension. Is that fine? And because they set it at equilibrium, this is equal to what? 0. So we have Fg plus Fe minus what? Tension. Which automatically means tension, if I bring it to the side, becomes Fg plus Fe. Okay, once you see this, it becomes easy, because now your T, what is my force of gravity? It's mg plus, now what is my electrostatic force? K, Q1, Q2 over R squared. I hope that makes sense. All right, so what is the mass? T. What is the mass? We're given 7 grams, when we must convert that to kilograms. 7 divided by what? 1,000. What are we going to have? 7 over 1,000 multiplied by 9,8 plus, what is this now? 9 times 10 to the power 9 times, what is my Q1? 32 times 10 to the power what? Negative 9 times, you gotta help me here with space, 55 times 10 to the power negative 9. Are we there? Everything divided by, what's my distance? 0,025. Don't forget, it is squared. Can we put all of this in our calculator just once and make life very easy for us? All right, so what do we have? We have a bracket there. We have 7 over what? 1,000. That is converting to kilograms. Remember, in physics we work with kilograms, times 9,8, close the bracket, plus we open another bracket, we just put it exactly what we have there, times 9 times 32 times 10 to the power negative 9 times 55 times 10 to the power negative 9. All right, and what do we have? 0, what? 025 squared. And then can we close the bracket? And final answer, 0,0939. That is the value of our tension. All right, the value of our tension. So let's quickly write that down. Quickly, let's write down what we got there. Okay, I hope we did all our computing correctly. All right, so 0,0939, which is 0,094. All right, T therefore is 0,039. 0.939 newtons. And if you want to write this in standard form, it becomes 9,3 times 10 to the power negative what? 2 newtons. All right, and that's what we do. All right, 0,0939, and then so writing like that, 9,3 times 10 to the power negative 2 newton, and that's what we have there. All right, so there could be so many rounding off. We could round this off as well to be 0,1. All right, could be rounded off 0,1. Could be rounded off here as 9, what? 9,4 times 10 to the power negative 2 newtons, depending on how you want your answer to be. That is how we calculate our tension there. Lovely question. Again, throwing another light into how questions are dealt with. All right, let's run through to the other section, because there are two. One is on force and the other one is on electric field. Define electric field at a point in words. Now, I'm going to skip that question because we answered just a while ago. Draw electric field pattern for two identical positive charged spheres, all right, placed close to each other. Remember that if they are positive, what's going to happen? They are going to repel each other, and they said they are identical. So try to make the number of arrows to be the same, all right? We did this in our first video. All right, we did this in our first video. Remember, these lines must not touch each other. These lines must not touch each other. And because they're identical, you see, I'm actually trying to do them the same way. All right. I have two there now that I've added. Okay, these lines must not touch, remember. I have two that I've added. And it must be going where? Out. Go back to the first video. In case you're getting this for the first time, go back to the first video. You'll be able to get this is grade 10 concepts now. We draw our electric, and you have your marks there. Okay, quickly, let's run to calculations. A negative 30 macrocoulomb point charge Q1 is placed at a distance of 0.15 meters from a positive 45 microcoulomb point charge Q2 in space, as shown in the diagram below. So net electric field at point P, which is on the same line of the two charges, is 0. Calculate x, the distance of point P from charge Q1. Okay, we're going to run through this with the speed of light. Our focus is on P. All right, guys, before you start this, start with the free body diagram. Okay, P is a positive point charge, which we take as what? A positive. So, if that is my P, let's start from Q1. Negative here, positive here, there's a force of attraction. I hope that makes sense now. And can I call this, I'm dealing with electric field, so I'm going to call this E1. Okay, what about positive on another positive? It will repel. And what do I have? E what? 2. Try to make the length a bit equal, because the question says that my E net is equal to what? 0. And what is my E net? Okay, I'll take right as positive. Take right as positive space, and I just do that there. So E net now, if my right is positive, my E1 is going to be negative. So I would now have E2 plus negative what? E1. So my E net, which is 0, is E2 minus E1. What does that mean? It means my E1 is actually equal to what? E2. How do I calculate my E1 now? K Q1 over R squared equals to K Q2 over what? R squared. Okay, let's do the maths together. What is my K? I'm dealing with Q1 now. 9 times 10 to the power. Okay, I want to do something. I want to show you. You need to learn a few things here to make mathematics a bit more fun. If you can divide both sides by K, all right, automatically this K divides that K. If you divide both sides by K, you need to learn that trick. Q1 over R squared, Q1 over R squared, therefore becomes what? Q2 over R squared. What is my Q1? 30 times 10 to the power negative 6 over, now Q1, between Q1 and R and P, that's the distance, dealing with Q1. Q1 and P, let's explain this for clarity. Q1 and P, the distance is what? X, and it's squared there. What about between Q2 and P? All right, what's my Q2? 45 times 10 to the power negative 6. And what's the distance? It is 0.15 plus X, and we square all that. Now I know it's a question of mathematics. We're going to make it easy, cross multiply. 0.15 plus X all squared multiplied by 45 times 10 to the power negative 6 equals to, no, we're cross multiplying. This is 30 times 10 to the power negative 6 equals to 45 times 10 to the power negative 6 x squared. Divide both sides by x squared. Alright? I'll show you something later on so you can get a grip of that. Alright, we can divide both sides again by 30 times 10 to the power negative 6. 0.15 plus x. Please don't expand this. If you expand, you're going to create more mathematical activities for yourself. 45 times 10 to the power negative 6 over 30 times 10 to the power negative 6. Now we have an expression. If you check our first video, we did explain this. A squared over b squared can be written as a over b all squared. That's mathematics. Which means I can now rewrite this as 0.15 plus x over x all squared equals to, I can get an expression for that. That is basically saying 45 divided by 30, which is basically saying, alright, 45 divided by 30, what do I have? I have 1,5, alright, 3 over 2, 1,5. But remember now, I can easily look for the square root of both sides. So what am I going to have? 0,15 plus x over x equals to, what is the square root of my answer here? 1,2247. 1,2247. All right, I'm going to keep my answer on my calculator, 2247. What do? We cross multiply. 0,15 plus x equals to 1,2247x. Can we now move this over to that side? 0,15 equals to 1,2247x minus 1x. So that gives me 0,15 equals to 0,2247x. And therefore, what do? We divide both sides by 0,2247. 0,22. I want you to notice I have not gone to my calculator because I still need my original answer. You only round off at the end. Remember what we did here was to subtract 1. So my answer was 0,2247. So now I need 0,15 divided by my correct long answer. And my answer now is 0,667. 2 decimal places, my answer is 0,67 meters. And you have 5 marks again. Question done. All right, let's see. Do we have more time? If we can pick one more question, and so we have 3 questions done in this session. All right, here's another question. A positive point charge Q1 of magnitude 5 microcoulombs is placed 10 centimeters away from a negative point charge Q2 of magnitude 5 microcoulombs. All right. So a positive point, Q1 is positive, Q1 is positive, and Q2 is negative. Draw the electric field lines for the 2 charges. All right. Since they are identical, let's positive. And this is what? Negative. What are we expecting? We're expecting, all right, a flow there. We're expecting all of that. And you're just fine. Remember, they're identical. We need to have the same number of lines because they have the same magnitude. And this is your 5 what? Microcoulombs, negative 5 microcoulombs. You've done 3 marks. State Coulomb's law. Okay, please go back to our first video and you should be able to state the Coulomb's law by now. The magnitude of the electrostatic force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance. Please go back to video number 1 and state. Calculate the magnitude of the electrostatic force exerted by Q2 on charge Q1. All right, what do? We are looking for force. These are just basic questions now. What's my formula? F equals to K Q1 Q2 over R squared. What is my K? 9 times 10 to the power 9. What is my Q1? 5 times 10 to the power negative 6. What is my Q2? Ignore the signs. The signs will just tell you the movement, the direction. Now, what is my distance? We convert these 2 meters by dividing by 100, and that will give me 0,1 squared. Okay, what's my answer? You see, this question is quite straightforward, and some of you will be praying we get this in an exam. 9 times 10 to the power 9 times 25 there, times 10 to the power, I'm just doing mathematics now, negative 6 will give me negative 12 divided by 0,1 squared, and my answer is 22,5 newtons. 22,5 newtons. The question says the magnitude, so we don't need the direction. How does the magnitude and direction of the force exerted by Q2 on Q1 compare to the magnitude and direction of the force? No calculations are needed. All right, your answer here in 7.3 is actually magnitude will be the same magnitude, but what? Opposite direction. That automatically tells you Newton's third law of motion. If object A exerts a force on object B, object B will simultaneously. We mentioned this again in the video number 2. All right, look at this. How will the magnitude of the force exerted by Q1 on Q2 change if the distance between the 2 charges is increased 3 times? Distance between the 2 charges increased 3 times. All right. Q1, Q2. Now my R is no longer R, but 3R. 3 times. So I'm going to have 3R squared. And what am I going to have here? K Q1 Q2 over 9R squared. If you go back to our second video, we did explain all of this. This is going to be 1 over 9F. That's how it's going to change. It's going to be a ninth of my original force. All right. And you could leave your answer and say 1 over 9 multiplied by 22,5. But the question says, how will the magnitude? How? So we don't really need to give a final answer there. It will change by a factor of 1 over 9. Calculate the net electric field at a point 2 centimeters from Q1 between the 2 charges. Okay, let's go back to, we need our diagram now. We have a point. They said it's 2 meters from Q1. All right, so I'm going to create a point there, which is from here to here, it's 2 centimeters. All right, let's make it X. Okay, let's do that. What are we looking for? The net electric field. Free body diagram first, because it's a point charge, it's going to be a positive, it's a point. Our Q1 is positive, and our Q2 is negative. So let's draw a free body diagram at X. Due to Q1, there's going to be a repulsion, all right? So I'm going to write Q1 there. I hope that makes sense. This forces this to go this way, positive, positive. What about this negative? It's going to attract my X. So I actually have what? E2. Okay, take right as positive. Take right as positive. What do we have? E net now equals to what? E1 plus what? E2. Okay, so E net will be equal to K Q1 over R squared plus K Q2 over what? R squared. Just want to do this and hit the 1 hour mark together. What are we going to have? 9 times 10 to the power 9. Remember, they are both positive because they are in the same direction. What is my Q1? 5 times 10 to the power negative 6. What is the distance? I'm using Q1 now. Distance between Q1 and X. 2 centimeters divided by 100, you have 0,02. And that should be all squared. Plus 9 times 10 to the power 9 What is my Q2? Again, it is 5. 5 times 10 to the power negative 6. But the distance between Q2 and X now is 8. Remember, the whole distance here is 10. The first section is 2. We are left with 8. So that is 0, what? 0, 8 squared. All right. All we need to do is to run to our calculator. What are we going to have? 9 times 10 to the power 9 times 5 times 10 to the power negative 6 over 0,02 squared. We add the other one, all right, which is 9 times 10 to the power 9 times 5 times 10 to the power negative 6. So the difference actually is the distance between them squared. And your answer is 119531250. All right. Just write down the answer like that. 11953. 11953. 11953. Or we can actually use standard forms now. Shift, okay, shift, mode, no, let's delete this. Okay, let's make sure my answer is still there. Shift, mode, 7. We want 2 decimal places with the first number, which gives us 3 digits. 3. 1,20 times 10 to the power 8. All right, you may need to rewind the video to see what I did there. 1,20 times 10 to the power 8. I'm looking for net electric field, so it must be newtons per coulomb. And you have 6 marks. All the questions done there, you have 18 marks. All right. It's 1 hour session already. All right, so this is where we end this session. I believe that we've been able to help you with electrostatics, both from grade 10, grade 11, and then most importantly, grade 12. All right, thank you for joining us again in this session. Just to let you know, this again is a production of Krazifizix, and we are always out there to be of assistance to you in any way. Send us an email, send us a message on how we may assist you better with our production. Remember, we have our science materials, which are also available for your use. We have grade 10, grade 11, and then we have grade 12. All right. So that's the grade 12 material. We also have our maths material. More information you would find on our website, www.krazifizix.org.za. Okay, this is Bishop signing out again. Thank you for joining.